Yo, what's good? Welcome back, geometry lovers, to How to Geometry. Today, we're diving into the world of conditional statements and their variations. A conditional statement is your classic if-then setup. Flip that around, and you've got the converse. Take the original, negate both parts, and that's the inverse. Then negate and flip for the contrapositive. Finally, when both the conditional and the converse are both true at the same time, you've got a biconditional statement using if and only if. Master these, and you'll be a logic pro in no time. So let's get it. All right, so let's look at some conditional statements. All right, so the basic conditional statement looks like this. So if P, then Q, right? P and Q can be anything. Any statement, that is. So P is typically the hypothesis, and Q is generally the conclusion. So remember that the hypothesis, it's always the part after the if. And the conclusion is always the part after the word then. So if P, then Q. So if hypothesis, then conclusion. So you might see it in this shape here. So if P, then Q. It'll be P with an arrow pointing towards the Q. So if P, then Q. So let's see an example. If I live in San Antonio, then I live in Texas. So the hypothesis, or P rather, is I live in San Antonio. And then the conclusion, Q, I live in Texas. Again, the part that's after the if is the hypothesis. And then the part after then is the conclusion. And this is the basic setup for a conditional statement, right? If, hypothesis, then conclusion. Now you can literally sit here and make up infinitely many conditional statements, talking about whatever you want to talk about. If P, then Q, and let P and Q equal whatever statements you want. Now, whether they're true or false, that's another story. They're either going to be true or false. This particular one, it's called a truth value. So this particular conditional statement is true, right? If I live in San Antonio, then I live in Texas, right? San Antonio, Texas. Let's go. Every conditional statement can be rearranged and rewritten into three other different variations, which we're going to cover all three right now. So after the conditional statement, right, the conditional statement is always the initial, the first statement made. It's typically stated, this is the conditional statement. And then it'll either be given to you or you have to create one. And from that, you can create the other three. All right, so the converse of a statement, it states, if Q, then P. So the converse switches the hypothesis and the conclusion. So the converse of the conditional statement, if I live in San Antonio, then I live in Texas, would be as follows. Right, if I live in Texas, then I live in San Antonio. So now the conclusion in the conditional statement comes first, right after the if. And then the hypothesis from the conditional statement comes second after the then. So if I live in Texas, then I live in San Antonio. Now, the truth value for the converse may or may not always be true. In this particular case, if I live in Texas, then I live in San Antonio. That's not necessarily true. This is actually false. And this is because you could live in Texas, but not live in San Antonio. Right, you could live in Houston. Let's go, throw up the H. You could live in Dallas, right, home of the Cowboys. Or you could live in another city that's not San Antonio, but still live in Texas. So this particular sentence is, or the converse is false. Whereas, right, the conditional statement, if I live in San Antonio, then I live in Texas, this was a true statement. Right, San Antonio is definitely in Texas. And if you live in San Antonio, then you live in Texas. So the converse doesn't necessarily have to be true. It could be false. It just depends. Now, if the converse is true, then you would have what we call a biconditional statement, which we'll get to that in a minute. All right, next we have the inverse. What the inverse does, it takes the conditional statement and it negates the conditional statement. So negates basically means to void or cancel out or do the opposite of, right? Like whatever the conditional statement is, and if you negate it, well, then the conditional statement's not happening, right? It's the opposite. It's working in the word not. So what this looks like, and the symbol that we use for negates, it's a little tilde. It's a little squiggly line, but this is a tilde. Basically, it means not, right? It means not. So if not P, then not Q, meaning you're going to negate P and negate Q. You're going to work the word not in somehow, so it makes sense grammar-wise. So going back to our conditional statement, the inverse of the conditional statement would be if I don't live in San Antonio, then I don't live in Texas. So we take the conditional statement. If I live in San Antonio, then I live in Texas. Then you work in the word not. So you're negating both the hypothesis and conclusion. So if I do not live in San Antonio, then I do not live in Texas. And now, is this true or false? That's the question. I don't live in San Antonio, then I don't live in Texas. That's not necessarily true, because if you don't live in San Antonio, you could live in either Houston, Dallas, El Paso, Lubbock, some other town that's definitely in Texas. So this particular one is false. So here's an interesting fact. When you're writing these out and you're analyzing if they're true or false or not, an interesting fact is that if the converse is false, then the inverse is also false. Right? Whatever the converse is, the inverse also is. So if the converse would happen to be true, well, then the inverse would have to be true as well. It's a pretty interesting fact. So the inverse and the converse will always have the same truth value. All right, so let's look at the fourth conditional statement, or statement rather. The contrapositive. So what the contrapositive does, it switches the hypothesis and conclusion, just like the converse basically, but it also negates it. So if not Q, then not P. And remember, Q and P, Q is the conclusion and P is the hypothesis. And these two statements can be anything. At the moment, we're looking at living in San Antonio and living in Texas. So this contrapositive statement, following what we've been talking about, is going to be so if I don't live in Texas, then I don't live in San Antonio. This would be the contrapositive. So if you want to think about the truth value here, so I don't live in Texas, okay, then I don't live in San Antonio. Well, that has to be true because San Antonio is definitely in Texas. So if you don't live in Texas, then you don't live in a city that is in Texas. So this would be true. And another interesting fact is that whatever the truth value is for the conditional statement, since the conditional statement was true, then the contrapositive truth value is also true. So conditional statement, contrapositive will have the same truth values, and the converse and the inverse will also have the same truth values. So everything is based off the conditional statement. Now, the conditional statement could be true or false. It truly could go either way. But everything else that we discussed will still fall into place, right? And then the truth values you just have to analyze and then really think about it to see if they are true or false. But conditional statement, contrapositive will always have the same truth values. Converse and inverse will always have the same truth values. So recapping, the converse switches the hypothesis and conclusion. Inverse negates the conditional statement. And we use the little tilde that means not. It works in to both the hypothesis and the conclusion of the conditional statement, right? The hypothesis is still after if, conclusion is still after then. The contrapositive, it switches the hypothesis and the conclusion and negates them both, right? That's what the little tilde means. So if not Q, then not P. All right, and then the last topic is a biconditional statement. A biconditional statement is when the conditional statement is true and its converse is also true at the same time. When this is the case, you can write the biconditional statement as P if and only if Q. So P if and only if Q, or you could abbreviate it IFF, if and only if. So hypothesis, if and only if conclusion. Let's see an example. So if I passed the test, then I scored higher than a 70. So the hypothesis, the part after if, I passed the test. And the conclusion, the part after the word then, I scored higher than a 70. So this is true. All right, if we consider its converse, so remember, converse switches the hypothesis and conclusion. So the converse, if I scored higher than a 70, then I passed the test. All right, this is also true. When the conditional statement is true and the converse is true, you can write a biconditional statement. Otherwise, there is no biconditional statement and a biconditional statement doesn't exist. So this biconditional statement would be I passed the test if and only if I scored higher than a 70. So it is true both ways. So you combine P and Q using if and only if. And it doesn't really matter the order. Like you could have stated it, I scored higher than a 70 if and only if I passed the test. Which again, it's literally the exact same thing. So that's a biconditional statement. As long as the conditional statement and the converse are both true at the same time. All right, so hopefully this helped someone. Be sure to subscribe, comment, let me know what you guys think, and I'll catch you guys in the next video. Peace.